Welcome back, detectives. We're going to do part 2 of this clue, and it's about horizontal translations. And horizontal translations can be a little tricky, but the main thing that you want to remember is that when you translate an equation horizontally, it's going to slide along the x-axis. So your x values change, not necessarily your y values. Your y values stay the same, but your x values change. Now, I want to point out something to you. Up here, when I had my here and here, when I had my two table of values, I said when x is 3, y is 4, and that was wrong. X is 3, y is 3, so I changed it here. The other thing that I've done that you'll want to pause and do is go ahead and plot the original equation f of x equals x. And now I want to know what happens when I translate my equation to the right, and I want to translate it 4 to the right. So let's go ahead and plot these points. So I'm going to keep f of x the same, -2, but I'm going to move -2 to the right. All right, so I'm going to take x is 0. Well, I'll do it down here. X is 2, and if I move it to the right 4, 1, 2, 3, 4, it goes right there. And then this one will go right here, and this one will go right here. 1, 2, 3, 4. And you can see what I'm doing. I've just moved it to the right. And I'm going to go ahead and quickly draw this line. Something like that. And I want you to notice what the equation of this line is. It's 1, 2, 3, 4, f of x equals, still the slope is x, but now I have a negative y-intercept. It actually looks like it's moved down as well, doesn't it? It's actually moved down because if we looked at our equation, it's exactly the same as this equation up here that we wrote, f of x equals x minus 4. And so what we've done is we actually have the same equation. So even though it's the same equation, it's not the same kind of translation. Vertical and horizontal translations of linear equations look the same, except that they are different parts of the line. So let me show you what I mean. Here's a Desmos calculator, and right now I have my red line f of x right here, my red line f of x, which is f of x when b is 0. So it's just f of x equals x, okay? Now I want you to look at my blue line, and I've rewritten my equation as y equals x plus c, whatever c is. And I want you to notice something. When I move the c, I have this slider. I'm going to move it back to 0. Not what I wanted to do. Having trouble finding 0. There we go. When I move it to 0, now I want you to see what happens. When I make the c positive, what happens to the line? Does it slide to the left or does it slide to the right? So I'm going to make the c positive and watch what happens. What's it doing? I'm making my c positive, but my line is sliding left, isn't it? And then when I make my c negative, it slides to the right. So the thing about horizontal translations is that it's like it does the opposite of what you would expect. All right? So that's a key thing that I want you to notice. So we even though we slid our x values to the right, the actual equation of the line is moving the opposite direction. So let me show you what I mean. So here we have x let's see, we added 4, right? Plus 4, y is our coordinate notation. But the actual equation of our line is f of x equals x minus 4, meaning that the x has a minus 4. So it's just a little wacky in that it's sort of the opposites. All right. Now let's do the same thing for our exponential functions. Our exponential functions, this time we're going to I'm going to pause it and graph my exponential functions. So you do the same thing. Okay, so I didn't draw in the line this time because I'm so terrible at drawing those exponential functions. So I just kept the point so that you could see the shape of the curve. And I want to go ahead now, and this time I'm going to I'm going to subtract 3 from my negative 2. So I'm going to move my negative 2. I'm going to keep the f of x the same, but my negative 2 is going to be in a different place. I'm going to move it to the left, negative 3. So instead of it being negative 2, it's going to become 3 to the left, which would be negative 5. So I'm going to actually write that right here, negative 5, and then it's going to still be a 1/4. All right. I should have done that over here as well, but I didn't. So I'm going to go 1, let's see, 2, 3, 4, 5. So that would be that one. And then I'm going to take this point and move it 5. 1, 2, 3. Sorry. I'm going to move it 3. 1, 2, 3. So that would be negative 3. No, negative 4. And 1/2. And then this point right here, I'm going to go 1, 2, 3 there. And that would be negative 3, 0. And I'm not writing very neatly here, but you get the idea. 1, 2, 3 would go there. And that's actually the 1 translates to the negative 2, 2. So that one goes to that one. You can see where they go. And then this one, 1, 2, 3 goes there, and this one goes 1, 2, 3 goes there. So you can see that my graph of my exponential function has shifted to the left, negative 3. All right. Now, though, what I want you to do is I want you to think about what this equation would look like. So this one I wrote here, I wrote this one, f of x equals f of x ignore that. This one, though, I want to think about what the equation of this line is. And the tricky part about this is that the equation is actually going to be f of x, f of 2 to the x plus 3, f of 2 to the x plus 3. So even though I actually moved backwards, my equation is x plus 3, f of 2 to the x plus 3. And I'll show you again on the Desmos calculator because that's where we can see it really happening. So here we have, I'm going to hide these for now. Okay, here we have 2 to the x plus c. So that was the original one, the c being 0, okay? So it's f of x equals 2 to the x power. Now what I want you to do is I want you to look at d of x, which is 2 to the x plus 3 power. And what happens is my equation is actually shifting to the left. It's shifting to the left. So when x was, let's do this one up here. When x was 1, y was 2. Now when y is 2, and and we add 3 to our x in our equation, our actual graph shifts 3 to the left. So again, it's sort of a backwards thing. So it's just a little tricky when we're graphing. So if we're going to graph it, and we know we're doing a translation, then we just shift everything. But if we're going to write the equation for it, we're going to change the x value, but instead of adding or subtracting 3, we'll add 3, or instead of adding 3, we'll subtract 3. So it just gets a little confusing. So here's my coordinate notation for this one. My coordinate notation was I did x minus 3 y, because notice that my values shifted to the left. My x values shifted. But when I wrote it as an equation, I wrote f of x equals, or f of, let's do it this way. Let's just write it. If we wanted to write the equation of our line, then it would be y equals 2 to the x plus 3. All right? So that's how we do horizontal translations. And again, it's just a little tricky in terms of thinking it's the backwards version of it. Now, the things that I want you to remember about this are that vertical translations shift the graph up or down. So, and we change the y value. So if we're going to write it in coordinate notation, we do x and then y plus or minus, right? So it's going to be a plus or a minus, one or the other. So our y shifts up when it's a plus, and it shifts down when it's a minus. And when we write the equation, all we do is we take the function, whatever it is, and we add or subtract 3 to the function. With a horizontal translation, it shifts the graph to the right or to the left, and the change is still made to the x value, or instead of the y value, it's made to the x value. So we might add or subtract the x value in our coordinate notation. But when we look at our equation, the shift is the opposite. It's the reverse in the equation. So f of x minus 3 means you actually shift to the right, or f of x plus 3 means you actually shift to the left. All right? Both of them, we're changing things in the, we change in our horizontal translation, we change the value of the x. So notice that we did x 2 to the power of x plus 3. But what actually happened in the translation was it was a shift in the opposite direction, in the negative direction. All right? So let me show you again on Desmos here. So notice that, that here, even though it's 2 to the x plus 3, my values actually shifted, the whole thing shifted to the left. And that is horizontal and vertical translations. And hopefully that makes some sense to you. If not, watch some of the other videos that I posted or do the experiments in the book. And I'll see you in class.